wait or access the other's computer which has the access, your friend's one, the door next to yours, okay? Anyone who has problem for accessing that network? Yeah, 20, 25, I'm not sure, that's the limit for the access at the same time. If this is Windows Server, there's no problem. But this is Windows 7, so you have that limit. Sorry. So that is why I'm saying you should be proactive. Get earlier, occupy the front-end computers, and access it, open it, and keep opening. First come, first get, okay? So, but even if you don't have access, you can access it on your friend's computer so that you can create or submit your file, download the material, whatever. By the way, okay, now you have the folders. The folder is uploading your file. Whenever you finish your lab exercise each week, you have 3, 4, 5, sometimes 7, 8, 10 files. Save your file, copy under your name folder, okay? And I'm going to copy this student folder each week. Probably 2-3 hours after the class. That is why I'm saying you're supposed to finish everything within class hour, at least 1 or 2 hours just after the class, okay? That means no homework, no assignments at home. At home, you should do something else for your studio work, other class, or your own work, not for this class-specific assignments or something to do. You should apply the technique you have learned in the classroom to other course or your studio work, real work, okay? Not just for this one. Practicing in real classes, not for this one. That's my intent. So this is the first time, so I let you know this kind of thing first. Now you know network access using this one. This is network computer. The computer name for this one is 504-main, and your computer name is 504-01, 02, 03, 04 through 30. 504-30 is the last one. Numbering sequence is from there to there. So you can find out your computers, your friends' computers, but you don't need to share each other. You can access this computer. But the problem is 30 computers cannot access at the same time. That's the problem. Not my fault. Sorry. So you have to proactive. That's my point. And the 2 backslash is exactly same to this Korean 1 symbol. Just over that just below backspace or just over enter key on your keyboard. Okay. Before getting started, we need to review course syllabus. Okay, please take a look at this course syllabus. And did you put your name on top of it? Don't throw this away, okay? You should keep it. And probably around in the middle of the course, if this is elaborated, I'm going to distribute this one again. Firstly, let me open this file so that we can share the screen on the screen. As I told you before, this is CAD for Interior Design 2B, but it doesn't matter the name exactly what it is. This is CAD and graphics, not the first class, second class. You have learned AutoCAD and geometric modeling using SketchUp. So our focus is on 3D geometric modeling and rendering using SketchUp. At the beginning of this course, And then we're going to move to 3D Max from next after next week, according to this course schedule. Firstly, you have to see this one, number, hour, week. Take a look at this number, what it means by. First week, 2 hours, and first week. But take a look at this one. Today, second, 4 hours, and second week. But next week, because of the scheduled holiday season, we have third week, but no hours, no class. So second week. But take a look at those series of four classes, 5 hours, okay? So that you can avoid weekend supplementary course or another meeting in Sunday or Saturday. That means the course gonna be ended in 7 p.m. Exactly 6:50 officially from September 27th through until October 18th, okay? 4 more weeks. Is that fair? Okay, great. So I told you how to read this column, and the second column shows you main agenda. Last week, we got some course introduction and student self-introduction for sharing some ideas and introduce yourself, and we did something. But this week, main agenda is 3D visualization basics using SketchUp with V-Ray renderer, okay? That's agenda. Topic is here. 3D visualization in interior architecture and some fundamentals of material, lights, camera, something like that. And lab exercise here. Fundamental modeling, but actually today, just V-Ray interface we will handle, and you should submit some rendering outcome from V-Ray using V-Ray plugin on top of SketchUp, okay? The rest of classes, you can take a look at main agenda, 3D visualizations first. That means we're gonna handle renderers first, rather than geometric modeling in 3D Studio Max. We can handle geometric modeling first, but actually geometric modeling is kind of harder work compared to rendering. So I would like to bring your attention and your interest first. So we will review V-Ray plugin on top of 3D Max and Mental Ray plugin. Actually, it's not plugin. It's sort of default application on 3D Max. We're going to handle renderers first, and then move on to geometric modeling. That's third agenda, geometric modeling in 3D Max. And then the last one, advanced 3D modeling and rendering issues using 3D Studio Max. And one note, you have to see midterm examination is scheduled in the middle of November, not in midterm October 18th. That's midterm season, but we're gonna have regular course in that midterm season, midterm week. Instead, we're gonna have an exam as scheduled November 22nd, okay? And you can review the rest of course syllabus content. But if the course schedule updated, I'll let you know through the website or updated printout version and so on. Any questions regarding this schedule or course syllabus? Okay, take a look at assessment, course assessment. as you find out, 5 assessments category, all they have same weight, 20, 20, 20, 20, and 20%. That means that midterm examination and final project, assignments. Assignments here means your submission each week, every week. Today, you will submit three different type of lab exercises. They are all assignments category, but it's pass-fail based, quantitative assessment, evaluation, and attendance 20%, exactly same weight to final project. That means, you know what, no need to say. And class participation 20%. It doesn't mean only the class participation. This includes qualitative evaluation for assignments and attendance, something else. Just simply imagine you gave up just 1 week. You may miss that week's assignment at that week. You can submit a week later, 2 weeks later. But anyway, your pass-fail based submission gonna be some problem. And attendance, participation, they all interrelated. So one absence, it makes kind of some correlated effect to your assessment. So that's why I focused on, and I put an emphasis on, you should concentrate on the course. What? So combine the course first, and kind of very aggressively involved in the course. Okay? Okay, I think that's enough for the course syllabus. Let's move on to the course material for today. Today's topic, 3D visualization. Until this week, still your computers and the main computer is under the maintenance. That means I need to reinstall entire software on this main PC, and your computers, entire 30 computers should be reinstalled, Windows and software, in next week, in Thanksgiving break, by me. So your computer doesn't have 3D Max so far, but SketchUp and some fundamental software already pre-installed using Ghost and some other software, but not yet prepared 100%. But you may know you have Autodesk student account, and you have your own some online registration key and some activation code. You can get it. For this semester, we're going to use 3D Studio Max 2014 design version. Okay? They're going to release 2015 version next spring. So we're going to use that version until middle of next spring. It changes very fast and so frequently. Anyway, we're going to use the latest version so that we can take advantages of the latest versions, sort of cutting edge and latest modifiers and functionality and so on. Okay, 3D visualization, let's get started. Here I listed up what to do today. By the way, you can take a look at the screen here, or you can open the file that I distributed you, okay, on your screen. So you can take a look at your screen and moving on at the same time, or take a look at my screen. Otherwise, you can open the course website. Google site offers you directly accessing the PDF file that I uploaded, so you can open one of them. Anyway, you should keep the pace with my course material so that you can catch up where we are, okay? First one is lecture, design computing and 3D visualization, 3D design visualization, and technical note and setup, accessing local area network in this room, and something else. Actually, we already did some of number 2, so I think we can skip it. And move on to lab exercises. Probably today's lecture going to be 1.5 hours. So we can use 2.5 hours lab exercise for rendering scenes in SketchUp using V-Ray plugin. Actually, I prepared 4 different lab exercises, but in probably mandatory submission for number 1, 2, and 3, not 4. We're going to handle 3 lab exercises, I think. So requirements, at least 3 images in JPG format, maximum 6 JPGs, okay? At least 1 JPGs for final outcome, or you can submit 2 each, so total maximum 6. 3 to 6 rendered images. Try to get your best render shot. That's what you have to do for today's lab exercise. Let me open design computing diagram first for bring your attention again. Actually, when I gave you some kind of special lecture or some additional lecture in last semester or the other chance if we had the same one. But actually, the review purpose, I like to show you this one again. Our department and most of you here aims to do design. That's our goal, right? In design, there is very, very important area should be done by human being. That's something creative and creativity area, creation. That means from nothing to something. That is very simple definition of design. That means we have to build any kind of concept, sketch, visualization, even word or some expression, whatever, should be added on top of nothing. So we have to create something. But that part is very important and something couldn't be done by computers. Only human being, by your brain, you can create something. But the goal for this diagram is design computing. So I would like to show you and guide you the role of design computing. For design, computing works at first, design authoring. Design authoring means you create a concept, a specific thing just brought up in your head, in your mind, that should be authorized by you in a specific shape. Just simply imagine that you have a pen and you just brought up an idea and you can draw something. You brought up idea in your brain, that's creation. And you sketch it, you sketch something, you draw something, that is authoring, okay? But in design computing, you author design using SketchUp, 3D Max, AutoCAD, Photoshop, Illustrator, even PowerPoint, MS Word, whatever you can use. That's computer software. So design authoring is the first one. And then you should develop it. Iterative process. Using computer, you can draw box, you can draw cube, long cube, small cube, and polyhedra, and sphere, and so on. That is design development. And using visualization, you can render it, you can line drawing, visualization, you can make and so on. So analyze your design using computers, simulation, and so on. So in this part, so-called computational processing, nowadays, no one used 100% handmade design process. We all use computers anyway, anyhow. So so-called this computational processing from authoring to development and so on to the final product is so-called design computing in a nutshell. This circle diagram simply shows you that process. So I told you this is human creativity area. Our goal is design. Means is computing technology and design computing. That's the focus of this diagram. Additionally, I would like to introduce you a new area. Creation and computational processing somewhere overlapped. That means, okay, computer, we believe that computer cannot create something, but actually can do in some way, somehow. This overlapped part is so-called AI. You know AI, artificial intelligence, right? Artificial intelligence or machine learning, machine perception, that is kind of cutting-edge computer science area, computer engineering or computer science area. In design domain, so-called design cognition is that term. Computer can create something from nothing. Simply say, Peter Eisenman developed his site planning based on site planning kind of environment existing design. He put the lines according to the environment, and computer suggests the building mass, building shape, according to specific algorithm. That kind of approach is similar to this one. He didn't design that building mass. He didn't design anything about that building. He just put parameters for that environment. So computer can suggest certain kind of geometry for that building. That is one type of that area, okay? Actually, we are not gonna dealing with this part, but there is kind of promising and very something difficult area. So I would like to introduce you this part. If so, what is our focus? You know today's PowerPoint slide title, visualization. Entire semester, we're going to deal with this area for second year student. But actually, my major and our goal, eventually we should go something information modeling. Modeling computational model, not just simply visualization. But our focus in this semester, in this classroom, gonna be visualization. If I have a chance, I'm gonna introduce more and more. But anyway, we should note that our focus is on visualization, geometric shape and their representation in computational manner. That's our so-called visualization. Visualize what? Design. What kind of design? Interior architecture design, building design, built environment design, okay? Your brain, and there is your idea. You just brought up certain kind of concept, certain kind of so-called idea. In conventional architectural 3D computer graphics, so-called CAD, CADD, CAAD, whenever you got your idea, no one can see it, right? Before you are telling your idea to others, or drawing a picture, or make something by hand, you should do something for representing certain kind of idea in your brain. No one can see something in your head. It's still only seen by you, only in your head, your universe of this course. That is why we have to draw something in terms of architectural standard named floor plan, elevation, axonometric, isometric section, and so on. They are all architectural symbol. We can say it. Design presentation, design representation. Mostly we can use PowerPoint for showing your idea to your instructor, studio class professor, or your friends, your clients in the future, right? We don't need to put digital here because you can draw by hand, drawing by your markers, your pencil, any kind of pen you can use. So all here, plan, elevation section, diagram, sketch, slide, pictures, animation. The picture here means you can take pictures by film camera, even digital camera. Anyway, that picture, that digital camera picture is going to be used some analog way, not total 100% digital way. Animation, design panel, printed media. You can print your ideas, or you can tie a book for your concept book, something else. This is conventional architectural visualization. Visualize something from your head. Very simple, right? The problem of this work is repetitive, never ending sometimes. Because your idea is not perfect, you have to modify your idea again and again. So you got idea A, visualize A, you modify A dash, you should revisualize A dash. You got B, so made B again, B dash, C, D, never-ending story, right? That's your usual walkway in your studio, conventional way. Also, your focus was geometric drawing and drafting. If you think about circle, you draw circle. But what if you just define, okay, just say computer, okay, I just start circle. Don't draw circle. Draw circle whenever I order it, something like that. That's totally different way. Hopefully you can understand what I mean by. But anyway, this is conventional way. But now we got the term modeling. Modeling. Okay, I would like to differentiate the term between modeling and rendering. But let's take a look at this slide first. The same brain, your brain, same idea, but a little bit different way. Formerly, we directly draw something using computers. But at this time, you can use kind of intermediate media, intermediate file, something else, named computational model. And you can extract this kind of representation, visualization stuffs from this model, not directly from your head. That's big difference is there. Same plan, 3D, sketch, pictures, even animation, anything else from the model, but not directly from your brain. You don't need to draw it. You can extract from your computational model. That means simply say one source, multi-use. How about this one source? Of course, it's not easy to create this model, computational model, properly, correctly. But good thing from this one is you don't need to get again and again some repetitive work. If you got some new idea, update your computational model. And all others going to be auto-generated. Because computer knows what is your model. So computer can create plan, elevation, 3D, sketch, animation, according to this model, not directly from your brain. Okay? You know what's different? So this computational model can be appended amount of more information about the building. That is building information modeling, okay? That is so-called BIM. But our topic is not on here, BIM. That's kind of next year topic. What's this year's topic? What is it? Great. Visualization. Visualization of computational model. Okay. But I would like to tackle the concept of BIM in the middle of our approach to computational model and something else. I would like to introduce you the difference between modeling and rendering quickly, and I would like to elaborate it later. The term modeling here is actually information modeling in this diagram. But whenever you say modeling in this semester, in this course, just simply regard it as geometric modeling. Eventually, we're going to deal with, whenever we say modeling, that's going to be information modeling about building. So that is BIM, supposed to be BIM, but again, not this semester. This semester, whenever we say modeling, whenever I say to do some model, doing modeling, that is geometric modeling, okay? Within building information modeling, geometric modeling is a subset of building information modeling. Simply say, this is BIM, and this is geometric modeling, okay? A subset of that. But our focus this semester is on here. Let's move on to the topic issue in digital design, media, and computing. The simple representation about design mode from Wikipedia. Actually, we have to know what is design, how to define design, something else. But instead, I would like to show you there are very particular 3 different modes in general design. First one is mode of thought, and then move to mode of expression. The last one, mode of production. First one, mode of thought, that's simply similar to the image I showed you before, brain, your idea in your head. In this mode, design is a plan, a scheme, on abstraction, abstract. Abstraction of something real, but that something real is only seen by you. So you have to make a concept or some replaced keyword or image, something like that. So that is why we say abstraction and a plan in this mode of thought. Actually, this is not our focus here, which generates ideas and concepts. On abstraction, which generates ideas and concepts. Very straightforward. Our focus is on actually here, mode of expression. Design is also a way of taking thought systems, blah, blah, and visual equivalence. Visual equivalence means in your thought, you thought circle. And then you should visualize it in circle. You thought rectangle, draw rectangle. That is visual equivalence, kind of. But what if you thought rectangle, but you express triangle? You draw triangle. They are totally different. But no one knows that's different because no one can see your brain, your idea, your concept. So whenever you say your concept, my concept is apple, you should draw apple or something like apple. That's visual equivalence, simply say. How to do that? Exploiting a media, a medium's unique qualities to maximize meaning. The term here simply means that if you want to use a pen, you know the characteristics and the function of the pen. So maximize the meaning, your meaning apple. So you have to draw an apple, shadow it, and make it something real apple. Exploiting your media, because at that time your media is pencil. Whenever you use computer, AutoCAD characteristics can be applied in this kind of expression. SketchUp, same situation. 3D Max, too. Finally, mode of production. Design is finally a way of making artifacts. Very straightforward. In this diagram, my keyword is here, medium. What is our medium for this semester? Yes, 3D Max. Or some other 3D software, because our course title is 3D graphics. So SketchUp 3D, 3D Max, Rhino, whatever we can use. But for your skill, for geometric modeling, mostly we're gonna use 3D Max. That's the scope and kind of scope of the class. Let's talk about design media. Design by hand. Design by hand for several thousand of years, I think. If we draw a line, this is 2013 now, and this is, I'm not sure, BC 20,000? I don't know the correct numbers, but anyway, when a human being created, they use that, something like that, right? How long? From here to somewhere here. Actually, it's shorter than this one. Here, 1944, 3, 5, I'm not sure. The first computer named ENIAC, I don't know, it's not important. That computer invented, and 1990, computers in design company, design office, architectural design office. 1998, I'm not sure the correct year, SketchUp released. 2000, thanks to hardware speed and cheaper memories, regular people could use Revit, so-called BIM. So as a design media, we only use pencil and something like pencil, very long time. And the period for using computer, really, really short. Very recent record. But anyway, nowadays, no one uses so-called design by hand. We always use design by computing. Even if you draw something else by your sketch, from your sketch, your expression, visualization at the first stage, anyway, you have to move on to computational manner. Design by pencil to computing. Thanks to computer hardware and software environment, the pencil is one of the most basic media of design. Pencil is media, another medium, computer. Not just computer hardware, computer software, Photoshop, AutoCAD, SketchUp, V-Ray, Mental Ray, all different type of media in the software category. Nowadays, we call our era to the IT era, proliferation of IT, information technology. What's new media for design? That is so-called digital design media, including anything else, computer hardware, computer software, even new type of pen, this one. This is touchpad pen. This is not touching because I connected my laptop. But anyway, you can draw using this one, this kind of pen. Even if this is just plastic pen, this one supports some very elaborated line drawing or some sketch mode in that way. The computational environment, device environment, going to be reset soon, so we will use the computer. But today I connected my laptop. Let's briefly take a look at the history of design computing. A short timeline of computer-aided design, very short compared to that line. On the left whiteboard, there is BC several thousand years, but I placed 1970s first to 2013. First CAD system, 60s. First solid modeler, 70s. First 3D building model, 70s, and CATIA, which designed Boeing airplanes, 747, and nowadays it designs buildings such as Guggenheim Museum, Frank Gehry's Disney Concert Hall at Los Angeles, something like that. Very non-uniform shape-based design by Gehry Technologies. And first parametric modeler and World Wide Web introduced 90s, and Revit released for the building, SketchUp, iPhone, iPad, some new type of mobile devices released to public in the middle of 27 that I remember. First CAD system named Sketchpad, developed by MIT, 1960. Ivan Sutherland and Stephen Kunz. The name for this is Sketchpad. But it looks like iPad, and name is something similar. And this is first 3D building model modeled by computers. This one looks like a 3D Max screen, earlier version of 3D Max. But this one, the screen capture of 1974. Popular CAD system, thanks to Autodesk AutoCAD. This is a screenshot, 1990 example on Macintosh computer. And the Revit 2012 version screenshot. So we're going to deal with something like this software, 3D Max, SketchUp. 1974 date back to around 40 years from now on. So when you learned 3D Studio Max, it's not kind of the latest one or cutting edge, very old, 40 years. But if you are dealing with some building information modeling, at least software side, that's going to be something latest one and something new, okay? My focus is here. Very short history, but this history changed everything in our domain work environment, AEC-FM environment. The term AEC here means architecture, engineering, construction. And the facility management, that's FM. So our domain, usually we say it is AEC-FM, architecture, engineering, construction, and facility management. I would like to bring your attention again using this diagram for understanding history of computer-aided design, history of CAD, history of design computing, all the same terms. history of CAD, history of design computing is a history of understanding what is design. How you understand design? What is design? You have your own idea probably, but sometimes people believe that something like this is design because it is a drawing of the product. Whenever you create or manufacture something like this cubic box, you have to drawing, industry standard symbols, elevation, plan, top view, front view, something like that. That kind of views and drawings usually believed something like design for that product. At that time, computer engineers made exactly same tool according to that understanding, that aspect. So geometric drafting in 2D was the major focus at the time, even using computers, AutoCAD, okay? But people changed perspective. 3D model, something like this, shaded 3D surface design. Did I call your name on the roster book? Roster book? Okay. I'm going to do that. Okay. First time, 2D was the focus, but people had been realized that, okay, modeling, surface modeling in 3D going to be design. So geometric surface should be modeled in 3D. So computer, software changed in that way. But in real manufacturing industry and architectural, especially in our domain, solid modeling is real product design because, you know, SketchUp model has hollow inside, empty inside. But in Revit, nothing hollow because that is, if that is a wall, no walls hollow. It's solid because of bricks, concrete, whatever, for that wall material. So that is real representation of that wall. People believed in that way. That is solid modeling. And then move to parametric modeling. Simply say, we have dimensions, so-called parameters. We can control this geometry in this way, height, width, depth, not the location point of this Cartesian coordinate point, x, y, z points. That's sort of mathematics way, not architectural or design way. That is parametric modeling, and people moved on to finally focusing on information. Geometric shape, all others are subset of this one. All others are included in this building information modeling. But actually, again, I put another emphasis on here. Green box. This semester, we will focus on this. Date back to 70s, okay? Not 2013. 70s. But don't worry, next year, we're going to move on to 1990s. Finally, get 2000. Or a year later, you should grow up. Okay, let's get back to the course material. So we can move on to the rest of the lecture and quickly move on to the lab exercises for today's your submitting your requirements, okay? Okay. You can visualize your own images in your head, in your brain. Whatever you thought, whatever you brought up right now, you can express it, you can represent it by hand, by computers, by any type of method, so-called medium that I mentioned today. Something like this. This is a sort of famous picture. courtesy from Wikipedia. Take a look at this picture. You can make something like this exactly or closely same to this image using 3D Max and V-Ray mentally. This is not a picture. This is 3D rendering. I didn't do that. So this is kind of famous picture which shows you realistic rendering, photorealistic rendering. Shadow casting and reflection, some out-focused, and caustics. Caustics means a lighting penetrating from here to there and refraction made, and some of different type of lighting source from somewhere. It make probably this one made by this one because it's green color. Another lighting source generate this kind of lighting, bright side of among this shadow. That is caustics. A sphere, a glass bowl, or a glass bowl, certain kind of objects usually generate this kind of caustics effect. This is really time-consuming rendering effect because for this one, amount of arithmetic, mathematic calculation required for computers. Anyway, this is render shot, and you can create this kind of rendering image probably in an hour, 30 minutes. I mean, generating this geometry. Rendering time is up to your machine's speed and some environment to set up. Usually, put very high resolution in 3D Max or V-Ray render or whatever. Sometimes this one single shot generated in a day or a couple of days. Another one done by Jaedong Park, ROTC, Jaedong Park. He made this one last year, exactly same to you for the midterm project, and submit this to the DA competition and got some entry award. Unfortunately, this year, DA 2013, it's not going to be held. It's bi-yearly. So this one for DA 2012 and next year, DA 2014 will be scheduled. But that's okay, you can work on for next year's submission or other competition for the midterm or final project in this semester. Anyway, one picked up example that I show you today. I'm going to show you all rest of your senior students' work. This one, anyway, his concept visualized in this way using 3D Max mentally rendering, appended Photoshop image edit, and some concept representation in text. Another one done by Seon Lee and Jin-Sung Kim, who's in now Korean Army. Jin-Sung Kim. So whatever they imagined, and this is kind of unrealizable structure. Anyway, they made this one in this representation, visual representation. Rest area, parking lot, elevator. I think it doesn't make any sense in architectural structure, but anyway, they visualize it, their concept. So they also got that award, DA. In a brief summary, I would like to encourage you to study and teach yourself fundamentals of computer science and computer engineering theory. Don't be nervous or serious for this one. I'm not talking about very detailed CS or engineering major. I'm talking about something fundamental level. You should be interested in this kind of theories for getting further issues. And computer hardware. Somebody knows nothing about your computer machine, your monitor, computer hardware. But you should be aware of how it works. What's the problem when you got some problem in hardware? You can search from anywhere and from your friends. Don't bring your hardware to my office anytime. I fixed amount of computers, laptops, free, but I'm gonna pay it. Computer hardware and network, internet. Now you have local area network access to this computer. In other words, you can hack this computer. I put all privileges, all permission to all of you guys. Just simply type 504 ID and 504 password for accessing this computer. And then you can remove your friend's name, except yours. If I see it, I'm not sure the man, this student, removed everything except her or his. Anyway, don't ruin others. Don't destroy your friends' folders. I know you don't do that by intent, but sometimes by accident you delete everything. I saw it, okay? That accident, that incident, the consequence for that accident is really severe. All zero score for that week. So don't do that. Deleting through the network, no trash bin, okay? Just wipe out on the network. There is no trash bin in network. You should know something about network and internet. That's why you need to pay attention to certain kind of things. Of course, Windows. Someone brings his new laptop to me, please install Windows 7. And I install it, free. But I'll pay it from now on, okay? So you should teach yourself. It's very easy. Installing USB, nothing else you need to use. Just simply plug it and install Windows, something like that. And don't ask me, ask to Youngtek, okay? Ask it. You are in charge of doing such kind of thing. If you don't have any solution or problem, and then bring it to me. Kind of filter, okay? Fundamentals of design computing theory is very important. Light gray, darker gray, and black. That means something important. Fundamentals of design computing theories, we're going to deal with in lecture. So one by one, week by week, you should pay attention to and should be keep the pace with me. And of course, computer software, especially specific applications for CAD and graphics tool. 3D Max Design, 2014 version for this semester. Even more things about design computing. There are a bunch of more things. Laser scan, 3D printer, CNC machine, paper cutter, virtual reality monitor screen, and so on. And I introduce you artificial intelligence area in our domain, the overlapped part between human creation and design computing area, AI area. That is kind of promising area. Just you mention something, your concept, apple, green, new thing, something like that. And the computer did something and pops up your design. And if you like it, click like. That makes your design to your studio design work. You don't need to draw any lines, surface, material, just type your concept keyword and computer will generate your design someday. Actually, that kind of design machine is kind of under the development, and some markup software and hardware already invented and introduced. Search YouTube or bmail.com. You can find out that kind of video, live demo video. That is something beyond our topic in design computing area. I told you, you're going to be in the industry, not 2013, probably 2018, 2019, sometimes 2020. That means amount of amazingly advanced technologies are common in that year. So your focus should be on 2012, 20, even 13, because, 2030. Now it's 2013. Because this is academia, not kind of private school for your job career. So I would like to guide you something like this one occasionally. One last thing, rendering theories, 3D visualization by computers, rendering. I told you what's modeling, and we're going to deal with geometric modeling. Now we need to differentiate modeling and rendering. Okay. Actually, it's very straightforward. You don't need to differentiate them, but I realize that most of students, especially second-year students, someone who's dealing with this kind of graphics at the first stage, you guys got something confused sometimes. That is why I brought up this one, the differentiate between modeling, rendering. You got some idea, and you made a computational model, something like this, a box, a cube. Modeling is a process to create computational model. This is so-called computational model. ing makes this model have a kind of process. To create model is modeling, right? So making this model, computational model, is modeling, and this is model. But also this is rendering, wireframe rendering of your model, okay? Rendering is, actually rendering doesn't mean the computational rendering, photorealistic rendering. If you draw something by pencil, by your marker, whatever, by hand, that is rendering too, okay? In your class, visual representation class, 표현기법. In that class, you need to draw something by hand. That is rendering too. But in here, the term rendering means computational rendering. The modeling is computational geometric modeling. That's the term we're going to use this semester. So modeling is to create computational model in process to make your own model. This is kind of something close to math, not on art or visualization. Because this one has Cartesian coordinate points in computer side, 0.0.0 and 10.0.0, and this one 10, 10, 0, something like this. Computer recognizes this one in this way and their connection, topology, and then make this one, comprehend this geometry. What is modeling? You can, rendering. You can render it in any way. Top view, this is rendering. named top view. This is rendering, front view, top view. This is isometric view, another type of rendering. When you got some shadow, here is the sun and sun rays, and it has shadow and some darker area, bright side, something like this. This is rendering, shaded view, shading, shader, something like that. If this one is looking picture, that is photorealistic rendering, okay? But in our domain, photorealistic rendering is not the correct answer always. What I mean is, this is good rendering. I showed you before, picture-like rendering, cups and some glass rendering shot. That is photorealistic rendering. But in our domain, design domain, architecture domain, interior architecture domain, sometimes we prefer to draw something like this line drawing in white and black because it looks some architectural. It looks some design drawing. But when you need photorealistic rendering, and then you can do that. But sometimes this one usually looks very artificial and very low quality if your model is not that good. Your material and lighting condition and so on, very complicated. We're gonna deal with that one in our class. Anyway, whenever you visualize, any kind of visualization should be rendering, okay? Several different type of renderings. Wireframe view, line drawing, black and white, some color fill, shade view, and so on. Examples are here. Rendering, coloring, another rendering, shading, another render, texture mapping, another rendering. This one's supposed to be sort of photorealistic, but it looks ugly. But anyway, it's kind of photorealistic rendering. More technologies, more techniques appended on top of this. What is modeling? To create this one, to create this kind of thing from your head, to comprehend, to understand your model for your computers, that's modeling. To create your model, that's modeling. So very different. Anyway, any kind of visualization should be rendering. Now we're going to deal with rendering today. In rendering, you will see amount of new terms, new keywords, lighting, direct illumination, indirect illumination, environment, HDRI, diffuse reflection, acoustics, blah, blah, too many words. That is why you got some confused or you got some difficulties in this kind of software. But don't worry, just remember, there is, anyway, light, and there is your object, and camera, that's it. So in this model, there is model, so-called target object. This is your target object. If there is no light, it's invisible because it's dark. Nothing can be seen without light. So there's supposed to be a light, usually lighting source. When you execute SketchUp, there is default SketchUp light. That is why you can see. But that kind of default light is very low quality. If you install V-Ray light, lighting effect is going to be really better. But the problem is you have to control that light. You don't need to control when you use default light. Anyway, light, your target object, and camera. At this time, my eyes, your eyes are camera. But if you install camera here and you select this camera, your view is going to be changed. But actually, camera is not that critical at this moment. We're going to deal with the camera in 3D Max. It's not that easy anyway, but not now. So only 3 objects in this universe of this course, in this UOD, okay? In the lighting, just simply there is sunlight and your lights and some variations, direct illumination, sunlight, indirect illumination, you know what are they, and the environment. No lights, but you can make your scene as a new type of environment using additional options, additional setting. We're going to do that, environmental setup today. And target objects, you have to remember the term diffuse reflection first. Diffuse means what you see on your object. Blue, red, gray, that is diffuse. Without diffuse, that they are all transparent, translucent. You cannot see anything. Thanks to diffuse, you can see color, see the material, object, and surface. What is reflection? You know what it is. Mirror. Reflection 100% reflects everything. That's mirror. Reflects 10% or a little bit glossy object, something like this, plastic. I'm not sure the ratio, 20%, 30%. Anyway, you can control that reflection. Refraction, 굴절. Caustics I mentioned before, right? Camera. So those three items and some important keywords I placed. Photorealistic rendering is totally thanks to global illumination, so-called ray tracing. Take a look at this one. Is this looking realistic? Why no? It looks realistic enough, but not perfect. Anyway, this one is looking something realistic, but there is a problem. Take a look at this wall. It's not visible. This wall's color is green, and this is red. So in the reflection on the bottom, they are something red, something blue. That's okay. But in real world, they're going to be affected on the other wall like this, something red color and some green color, even in this side. Because of global illumination, lighting source, ray of light emits from here to there and reflect here. So some red color, very light red color gonna be represented on this wall, and the green too. So this is global illumination, ray tracing based. You may find out global illumination. Actually, you may see GI. Turn on GI, turn off GI. Makes your computer very faster or slower. If you turn on GI, very slow, because it should be trace all the rays. What are rays? Here is the lighting source. We usually draw an arrow for representing sun ray, but actually it's not one single line. Millions of rays, and one by one should be calculated. Reflected, reflected, and this one reflected, again reflected to here, to there, and so on. You cannot anticipate how it works. But the mechanism here is totally same to our nature. That is science. Who invented or who developed the theory of this kind of issues? Famous man did it. 200 years ago, 300 years ago, I'm not sure. Who did it? Something about light. He wrote a book, Principle of Lights. Sorry, I'm not sure. Anyway, something like that book defines the mechanism of lights and its movement in physics. Thanks to his discovery, we can apply his theory to computers, trace all the rays one by one, so that computer can generate really same to real world vision. That is why we can get this kind of, actually not this one, the one that I showed you before. that one, glass, picture-like Wikipedia image. And you also can set up GI and ray trace option and so on, turn on caustics, turn on some additional advanced options. Even if they take time, you can turn on them and render it. And then you can create your own photorealistic rendering image using 3D Max in this semester. So this is something about photorealistic rendering, the mechanism, fundamental mechanism of that rendering. Exactly same to real world. Computer computes thanks to arithmetic and mathematical methods, which discovered by Newton a couple of hundred years ago. Exactly same to real world. That is why computer can represent some real world-like object. It's not fake, it's real. Okay? So I actually listed up some keywords. The reason for this one is you may see those keywords today in V-Ray renderer in SketchUp, even in mental ray renderer option in 3D Max. Don't be confusing or don't be nervous or even upset. They all are there. Lighting source, indirect, direct environment, on the object, surface, material, texture, diffuse reflection, refraction, self-illumination, emissive. Self-illumination is a different type of light. Special effects, blah, blah. All these terms are commonly found in any type of renderers, including V-Ray, mental ray, Brazil, or any other type of renderers. This is some breakdown of that one. So glossiness on the refraction, glossiness on the reflection, glossiness on the diffuse. Because they have such kind of characteristics, even if they are in different category. Okay, I think we can move on to lab exercise. Let me finish the lecture and quit the record so we can move on.